To get the cat feeder to dispense food without the cat ruining it, that took time. Here I'll tell you a short story of my journey. This cat drawing and this box of single parts is all I have left of the original machine. The whole design was meant to be modular, so each tube could be extended to a different height, therefore hold different amounts of food. Each tube was standard plumbing pipes, a screw cap on top, and a pressure fit into the base plate. Zip tie to hold the pipe in place at the base plate so the cat could not tear off the pipe. To turn the base plate around, I 3D printed an octagon shape that fit into the base plate center hole and a clamp on top to hold on to the axle. A 60 teeth pulley for the belt drive on the axle, 20 teeth pulley on the motor. My favorite motor for these kind of things is a worm gear motor. You can buy them with different specifications concerning voltage and revolutions per minute, so it's easy to find the right one for your application. For this project, I used a 40 revolution per minute 12 volt motor. The power supply for the motor is actually only 5 volt. That makes the motor go even slower, but the worm gear and the belt pulleys give the motor enough force to drive the base plate with food. To monitor the base plate's rotation, I added a micro switch that detects the holes in the base plate. Having food dispensed is one thing, refilling the tubes is another thing. I created this plate to put under the tubes with a lot of flanges to hold it in place, but 3D printing and small things are breaking off easily. Apart from the issues about refilling the tubes easily, the cat also figured out how to hack the machine. Unfortunately, I don't have pictures of the actual hacking. I caught the cat sticking its paws in between the tubes and forcing the wheel around. So new radical thinking had to be done. I had to kill my darling, the modular filling tubes, and go for a smooth surface with inside compartments like this. The circular compartment design also gave another advantage. By printing a bottom and a lid, the whole thing could be taken off the machine, refilled and put back in place. The first time the cat met this version of the pet feeder, it started hacking. By tipping over the pet feeder, it tried to force out food. Luckily, my design held and no food was spilled. So, on to next version. This new version 2.2 is built on top of a wooden box. I reused the dispense mechanism and the feeding wheel. The wooden box was designed with simplicity in mind. A plate for the base, sides, a top for the dispense mechanism and the control box, and a tray to dispense the food in. To ensure the cat could not move the box, I had to add some bricks to weight it down. Again, the cat surprised me big time. If there's a hole, it's going to investigate it. So the hole between the slide and the top had to be closed off. So back to the workshop, add a plywood plate to the hole, make a recess for the slide, mark and mount where the screws for the plate should be, and then put it all back together. Now the mechanical design is in place and working. How do I monitor and control the pet feeder? Inside the control box there's a Raspberry Pi, a motor controller, the power supply for the Raspberry Pi, an LED to show that the box is running, and wires for the motor, and wires for the switch that detects the base plate's position. The Raspberry Pi has a number of general purpose I/O meaning inputs and outputs. One GPIO is defined as input for the base plate position switch. Another GPIO is defined as output and is used to control the motor controller board. The motor control board again controls the motor to turn on and off the power. Because the motor uses more current than the Raspberry Pi can supply on the GPIO, the motor controller is inserted in between and supplied by external power. The state machine starts by initializing all the states in the program. After initialization, the program finds the next runtime from the configuration file and waits until that time occurs. When the runtime occurs, it runs for 2 seconds to get out of the current hole. It switches to next state and runs until the switch hits a new hole. Then it finds a new time and waits for the next runtime. This state machine completed the purpose, well, until every day hit, and then I needed a new function. I thought about different approaches to the pause mechanism, but the obvious one was adding a pause state. To enable me to monitor how the pet feeder was doing, I added a few messages in some of the states that I could read in my Home Assistant screen. At last, I found a machine that cannot be hacked by the cat. The cat learned the sound, so it comes whenever the feeder starts, and I can refill it every 8 feet. Please remember, like and subscribe.